Now, we're going to use a left Riemann sum to approximate, I don't know, something. I didn't really read what the problem was about. Apparently, we have a tank that is 10 feet tall. Yeah, that's what it says, approximate the volume of the tank. I just had to read. All right, 3 subintervals. Left Riemann sum should have been 2 times 50.3 plus 3 times 14.4 plus 5 times 6.5. And that came out to be what?
176.3 feet cubed.
Make sure you put your units, it says, indicate units of measure. All right, we'll come back to point values for each of these once we get through the whole thing. Part B is the approximation an overestimate or an underestimate. Well, what type of function do we have? We have a function that is decreasing. It says right there, decreasing function. Left Riemann sum will overestimate, we'll say decreasing function. And you'd write out a nice little sentence that says, the approximation is an overestimate because it's a decreasing function. And you feel really good about yourself, right? Part C, they give us a new model for the area, which is f of h. Based on the model for f of h, find the volume of the tank. So how do we do that?
Integral from 0 to 10 of that function.
I'm going to integrate that function from 0 to 10. Everybody good with that? Is that what you said? I don't know what you said. And what do you get? 101.3 what?
325 feet cubed.
Feet cubed. Everybody good with part C? Straightforward enough. Part D, water is pumped into the tank. The height is 5. The height is increasing at this rate. We're going to use our model from part C, this model right here, to find the rate at which the volume is changing. So we have a formula for the volume. The volume is the integral from 0 to whatever height we're going to of the function f. So when we take the derivative of that with respect to t for this related rate, we get dv dt equals f of h dh dt. And you're looking for dv dt. You know that you are interested in that when the height is 5, so you'll plug in 5 for h, and dh dt will be 0.26. So f of 5 times 0.26, f of 5 will come straight from there. And what do you end up with? 1.694 feet cubed per minute. Everybody good with that? Let's see here. Let's take a look at what the point values were for that. A military tank? Like kaboom, kill people. Oh, like a storage tank. Yeah, but it was like, I don't know. So part A, 1 point for setup, 1 point for the answer. Part B, 1 point for overestimate with a reason. Part C, 1 point for the integral, 1 point for the answer. And part D, 2 points for this and 1 point for the answer. And you'll note that that's only 8 total points. 1, 2, 3, 4, 5, 6, 7, 8. There was also 1 point if you had the units for A, C, and D. You had to have correct units in all 3 of them to get the 9th point. Everybody good there? Any questions in the Zoom on that one?
No.
Okay. How'd this one go? Good? Bad? Easy. That's great. I hope you got them all right, Tom. You didn't need to write the graph. Okay. Let's see here. I'm just going to pull up the scoring guidelines. I thought I had them up. Maybe I don't have them up. Oh, well, that's fine. Let's find the slope of the line tangent to f at x equals pi. So here's f of x. We want the slope of the tangent line, which means we need the derivative, which tells us that f prime of x is what? What's the derivative of cosine 2x?
-2 sine 2x.
And the derivative of e to the sine x ought to be cosine x times e to the sine x. And when we evaluate that at pi, you all right with that, Tori? You sure? You sure? You looked over at Melanie like you had no idea what was going on. Maybe you were looking at the clock. Clock? Let's call it clock. In hopes of being, your hair was stuck on your jacket. Bummer. Okay. F prime of pi, what do we get for that? That's -2 times the sine of 2 pi. What's the sine of 2 pi? 0. So -2 times 0 is still 0. So we end up with 0. And then plus the cosine of pi, which is -1. And then e to the sine of pi. Sine of pi is 0. So e to the 0 is 1. So -1. So f prime of pi is -1. Everybody go with part A? Wonderful. Part B. K is this function, h of f of x. All right. We want to find k prime. What's k prime? Using the chain rule, that becomes h prime of f of x times f prime of x. And we wanted to find k prime of pi. Is that right? So that would be h prime of f of pi, and then f prime of pi. And what's f of pi? What'd you get? What? -1 for f of pi. Do we agree with that? I'm looking for f of pi. Cosine of 2 pi is 1.
1.
And then e to the sine of pi, that's e to the 0, which is 1. So f of pi is 2. So h prime of 2, and then f prime of pi, which was -1. And so now we end up with negative h prime of 2. H prime of 2 is just the slope of h at 2. Well, what's the slope of this linear piece? Down 1 over 3.
-1/3.
-1/3. So our final answer is +1/3. Everybody good there with that one? Any questions, any issues on part B? Two of the points for this problem. That's the wrong scoring. That's the wrong scoring guide. Somewhere I have the right scoring guide, I thought. Maybe not. I don't know. I gotta find the right scoring guide. But two of the points here were for getting k prime of x. So make sure you write that expression. And then 1 point was for that. Everybody good with me? Let's talk about C. Part C gave us another new function, m of x. What was it? G of -2x times h of x. So find an expression for m prime first. What do we get for that? Product rule? g of negative 2x times h prime of x plus h of x times the derivative of g of negative 2x. What's the derivative of g of negative 2x? The chain rule, right? Derivative of the outside function evaluated at the inside function times the derivative of the inside function. So there's m prime. We want m prime of, what was it, m prime of 2. So that would be g of negative 4, h prime of 2 plus h of 2 times negative 2 g prime of negative 4. Everybody good there? What is g of negative 4? 5. What is h prime of 2? Isn't that the value we found a bit ago? Negative 1/3. What was h of 2? That one you got to find using that slope of negative 1/3. Negative 2/3. And then we got negative 2 times g prime of negative 4. What was g prime of negative 4? Negative 1. So we have negative 2 times negative 1, which ought to be a positive 2 there. And what does that become? Negative 5/3 minus 4/3, which is negative 9/3, which is negative 3. Good or no? Any questions, any issues there in part C? Everyone's good? Good, 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 good. Zoom, good?
Yes.
Wonderful. Great. Part D. Is there a number c in the closed interval -5 to -3 such that g prime of c equals -4? Well, two ways we could look at this. We could look at this, one in terms of the intermediate value theorem, or g prime. First off, before we even worry about if it's continuous, g prime goes from -3 to 4. Does that include -4? If you go from -3 to +4? Not
No.
necessarily. So the intermediate value theorem is not going to work for sure. So let's look at the mean value theorem. The mean value theorem says take the average rate of change on the interval, 2 minus 10, over -3 minus -5. That gives us -8 over 2, which is -4. So if g is continuous and differentiable, then yes, by the mean value theorem. And is g continuous and differentiable? We know that it's continuous and differentiable on that interval because g is a differentiable function. Good or no? Any questions on this question? How'd this one go? This one was pretty easy also. Yeah. K of x is f of g of x. So equation of the tangent line means we're going to need k of 3 and we're going to need k prime of 3. What's k of 3? K of 3 is f of g of 3. What's f of g of 3? Well, g of 3 is 6. So that's f of 6. What's f of 6? 4. So we've got the point 3, 4. And then we need to find the derivative. What's the derivative of k of x? It should be f prime of g of x times g prime of x. Right, chain rule? Everybody good there? So then we've got f prime of g of 3, and we already said g of 3 was 6, so we're looking at f prime of 6, g prime of 3. F prime of 6 is 5, g prime of 3 is 2. We end up with a slope of 10. Y minus 4 equals 10 times x minus. Good or not? All right. Zoom, you're good? You having a problem with your hair? You just look at the clock this time. See how much time we got left. Okay. Only 48 minutes to go. 48 more minutes of suffering, and then you can leave. What? I don't stop at 40 most of the time. Really? Do I really? You think I stopped 10 minutes early most of the time? How many times did you say I stopped 10 minutes early this year? Tom has got an issue with my class schedule. He thinks that I end 10 minutes early every day. So does that mean I need to make up that time? So are we behind some hours of class? Should we make that up today? Should we go over today? Oh, lucky you. Good thing I've been able to instruct you so well and giving you all that extra class time and learning. We'll continue to do that today. All right. Part B says h of x is g of x over f of x. You have to learn, Tom, that you'll never win. No matter what, I will always win. H of x is g over f. So we'll take the derivative of that. What is the derivative of that? Quotient rule? Denominator, derivative of the numerator, minus numerator, derivative of the denominator, numerator, squared. Good? We need to find h prime of 1. So we're looking for f of 1, g prime of 1, g of 1, f prime of 1, and f of 1 again. What are all those values? What's f of 1? It's like -6. So we got -6 times something over a -6 squared. And what do we have there? G prime of 1 is 8. G of 1 was 2. And f prime of 1 was 3. Everybody agree with us? I'm just trusting Tom, which is dangerous. -48 minus 6 over 36, that's -54 over 36. Divide an 18 out of both of those, and you got -3/2. Good? Wonderful, Tom. Good job. Excellent. All right. Was there part C? I bet there was. Evaluate the integral from 1 to 3 of f double prime of 2x. What's the issue with this? If it was f prime of x, the integral of it would just be, sorry, if it was f double prime of x, it would just be f prime. But since it's f double prime of 2x, what do we need to do to get rid of that 2x?
U sub or
U sub sounds good. U is 2x. Du is 2 dx. So we'll put in a 2 and a 1/2. We end up with 1/2 the integral of f double prime of u du. And what are our limits now? They're no longer 1 and 3. They become 1 times 2. And they become 3 times 2. Everybody good there? Don't forget to change the limits. We now have 1/2 of f prime of u from 2 to 6. Good? 1/2 of f prime of 6 minus f prime of 2, which is 1/2 of, what's f prime of 6? And what's f prime of 2? Looks like we end up with a positive 7/2. Good or no? Wonderful. Any questions on that? Zoom, you guys good?
I have a question on part B. So if we just have like h prime equals like the quotient rule with the x's instead of the ones, is that enough to get both points, or should we write out like plugging in the 1 for the x and then write the values?
You're saying you left this step back?
Yeah, I
Yeah,
just
that should be fine.
okay. Okay, thank you.
Yep. Other questions? Zoom, other questions? No? All right, let's do another problem then. This looks like a good one. Should we do this one? I think so. All right. I'll give you guys 15 minutes to work through it, and then we'll go through it. Ready, go. All right, part A, find the equation of the line tangent of the curve at -1, 1. So we have the point, we find the slope. That was easy. Plug in 1 for y, -1 for x. You get 1/4. Equation is y minus 1 equals 1/4 times x minus -1. Good? Part A, easy. Okay. Part B, also easy. Find the coordinates of all points on the curve at which the line tangent of the curve is vertical. If it's vertical, set the denominator equal to 0. You're not going to be able to find a specific x and y coordinate pair, just like one specific coordinate pair that works for that, because there are a lot of different values that could work for this, right? For example, the point 0, 0 works for this, doesn't it? Yeah, but it doesn't work up here. That's not a point on the curve. It has to be a point that satisfies both this and this. True? Isn't that what I told you, Tom? Has to satisfy that the derivative denominator is 0 and the function equals 2. Well, how do I know when that's the case? Well, I want to know when this is true and when this is true. That's just the solution to this system of equations. So x is equal to 3y squared. Well, when is x equal to 3y squared? Plug in the 3y squared for x and solve. That's how you solve a system of equations, right? You do substitution, solve one thing for one variable and plug it into the other one. That'll tell you when both things are true. Y cubed minus 3y cubed equals 2, or negative 2y cubed equals 2, or y equals -1. So the only value that will solve both of these is when y is -1. And if y is -1, x ought to be 3 times -1 squared, or x ought to be 3. So it's the coordinate pair 3, -1. Good? If you had a century, if Tom had a century, he would not be able to figure that out. Yet it only took me 1 minute. Something like that. Let's see. Let's see. It took me 1 minute. Let's see. 100 years. We're just going to neglect leap years in there because what's the point? That's 36,500 days, 24 hours. Oh, I think I just multiplied that by 25, not 24. Yeah, 24 hours in the day. How many minutes are in a day? 1,440. Is that right? Yeah. We'll just ballpark it at that. 1.26144 times 10 to the 9th. So let's see here. What is that? That's That's basically, I'm over 1 billion times smarter than you, Tom. That's great. Glad we were able to figure that out. All right. Everybody good with part B now? Had some time to digest that? We're all good? Yeah? People in the Zoom, are you good?
Yes.
Wonderful. All right, part C. Evaluate the second derivative at -1, 1. So to find our second derivative, we need to take the derivative of our original one with respect to x. So we had, what do we have? We had y over 3y squared minus x. So using the quotient rule, that should become 3y squared minus x times dy dx plus minus y times 6y dy dx minus 1 all over 3y squared minus x squared. And do I need to replace all the dy dx's with my dy dx? Yeah, no, we don't need to because we already found out what dy dx was at this point. It was 1/4, right? And then we know that x is what, -1 or +1? X was -1, and y is +1. So we'll just plug in all of these three things and then evaluate. So 3y squared ought to be 3 minus -1 ought to be 4. So we got 4 times 1/4. Then we got minus 1 times 6/4, which is 3/2 minus 1. And then this denominator is what we said 3y squared is 3 minus -1 is 4 squared is 16. So we got 1 minus, this is a half, so 1 minus a half is a half over 16, 1/32. Good or no? All right. Everybody good with part B though? I just want to make sure we're good with part B. All right, this is an important thing because oftentimes with ones that are implicitly differentiated, if you have multiple, if you have an x and a y in the denominator, in order to figure out when that tangent line is vertical, or if you have an x and a y in the numerator and you want to figure out when the tangent line is horizontal, you're going to have to solve that system of equations. All right, so you're going to have to set either the numerator or the denominator equal to 0, solve for one of the variables, and then plug that back into your original. That happens somewhat often. Usually you have to do it at least once on the test. Sometimes it's in the multiple choice, sometimes it's in the first. That's an important idea. Everybody good with that concept there? Have we done the grass clippings that are decomposing? We haven't done the decomposing grass clippings. All right, this is our next problem. You have 15 minutes to do the grass clippings that are decomposing, the decomposing grass clippings. 15 minutes. Ready? Go.